Hello, this is a section 2.2b lesson. In part A of this section we talked about the definition of fractions and some basic concepts involving fractions. This section we're going to talk more about the definition of fractions and some other basic concepts related to fractions, including things like fractions as numbers and improper fractions. So first thing is, let's review the definition of a fraction. And so with fractions we start off with a whole object of some sort, and then we divide that into several equal pieces. Each of those pieces is called 1 over b of the whole, and then a generic fraction a over b represents a pieces, each of which is 1 over b of the whole. So we start off with a whole, we divide that up into several pieces, and then we select several of those pieces. The number that we select is our numerator, the total number of pieces in the whole is our denominator, and that's how we get a fraction. First thing I want to talk about in this lesson is, what do we mean by equal pieces? And one point we want to make here is that some situations equal can mean different things. So let's illustrate what I mean by that with this simple example. I'm going to go back to our Army guys, and here's the question: show 3/8 of the collection of Army guys. So by definition, this fraction 3/8 means we take our whole in this case is the collection of Army guys, and we need to divide this into 8 equal pieces. So there's kind of already broken down into 8 pieces. We've already got 8 Army guys there, so we can consider each one of those Army guys to be a piece. But now we may say to ourselves, well, wait a minute, these Army guys aren't identical. They're all a little bit different. So can we consider them to be equal? Well, yeah, we can consider them to be equal. If we consider an Army guy to be an Army guy to be an Army guy, regardless of what he looks like, then all 8 of these Army guys are equal. So we have 8 Army guys here. So we're gonna, each one of those is 1/8 of the collection, and so 3/8 of the collection would just be 3 of those Army guys. We can select any of those Army guys. And so the point here is that when we divide our whole up into 8 equal pieces, we're considering each Army guy to be equal to every other Army guy, even though they aren't identical. Now let's look at another example that's going to illustrate again this point of what do we mean by equal. So let's show 2/3 of this shape right here. So 2/3 means that we need to take that shape and divide it up into 3 equal pieces, and we need to select 2 of those pieces. So we need 3 equal pieces. So what do we mean by equal here? Well, there's lots of different ways that we could divide this up into 3 equal pieces. Here are 2 examples of how we could break this up into 3 equal pieces. So here we have divided it up into three pieces that look like this. They're all long, skinny rectangles. And so we see here that we have divided this shape into 3 pieces that are all of the same size and the same shape. So all 3 of these pieces are identical. They look exactly the same. But now here's another way that we could divide this up into 3 equal pieces. We've got 1 long strip here, then we've got 2 kind of short and fat boxes here. So we've divided this into 3 pieces of the same size, but not of the same shape. So by size, what we really mean there is area. If we were to measure the dimensions of this rectangle and this rectangle and this long rectangle and calculate their area, we would see that all 3 of these are the same. And so in this right here, or in this way of dividing into 3 equal pieces, we have 3 equivalent or identical pieces. All those pieces are exactly the same. Here we've got 3 equal pieces, but they're not identical. They're equal in the sense that they have the same area. Okay. And so to summarize these 2 examples, to show a fraction or draw a picture of a fraction, we need to divide the whole into equal pieces. And equal could mean different things in different situations. As in the first example, equal means that an Army guy is an Army guy is an Army guy. In the second example, equal could mean that the pieces are identical, but it could also mean that the pieces are equal in area. So equal does not necessarily mean the same thing as identical. And so in the activities that we're going to do in class, we'll get some more practice in thinking about what do we mean by equal pieces. And in a given situation, equal could mean different things to different people. And that's okay. As long as we define what it is we mean by equal, we'll be okay. So this first example is going to illustrate what we mean by a fraction as a number. So this example simply says draw a picture of the fraction 2/3. Now notice that it's not 2/3 of something. There is no of there. And so this is what we mean by a fraction as a number. This fraction doesn't represent a portion of some physical object. It's just the number 2/3. And so what do we mean by draw a picture of this fraction? Well, first thing is we have to identify what the whole is. Now no whole was given here, so we're just going to draw a simple strip diagram for the whole. And so let's just draw a little rectangle here, and we're going to say that this rectangle here is the whole. Okay. So there we've defined what the whole is. Now this fraction 2/3 says we're going to divide this whole up into 3 pieces. So let's draw 2 vertical lines there to make 3 pieces. And then the numerator is 2, so that means we're going to select 2 of those pieces. So we'll just kind of shade in 2 of those pieces there. And so there we go. That picture represents the fraction 2/3. We took our whole, divided up into 3 pieces, and we selected 2 of those pieces. That's the fraction 2/3. Now next, let's define a couple of terms here. So in a fraction, a over b, if a is less than b, so if the numerator is less than the denominator, then the fraction a over b is said to be proper. And then if a is greater than or equal to b, so if the numerator is at least as large as the denominator, then our fraction is said to be improper. Improper doesn't mean that something's wrong with it. It's just a name for a fraction where the numerator is bigger than the denominator. So let's look at an example of an improper fraction. Let's take the statement 5/4 of a cup of water. So our fraction here, 5/4, the numerator is bigger than the denominator, so this is an improper fraction. So what do we mean by 5/4 of a cup of water? Well, let's draw a picture to illustrate what this means. So first let's draw the whole. So let's just draw a simple box here to represent our whole. So there's our whole, which in this case is a cup of water. Okay. Now our fraction is 5/4, the denominator is 4, that means we're going to divide that whole up into 4 pieces. So let's draw 3 horizontal lines like this to divide our whole up into 4 equal pieces. Those pieces don't look very equal, but we'll just pretend they are. And so there's my whole divided up into 4 pieces. Now the numerator is 5, so that means that I need 5 of those pieces. Well, I don't have 5 pieces there, so I need to draw a second whole. And so let's draw another rectangle the same size. And let's divide this up into 4 equal pieces again. And so now we need 5 of those pieces, so let's shade 5 of them. So there's 1, 2, 3, 4, 5. So there we go. That picture right there represents 5/4 of a cup of water. We define what the whole is. The whole was one big rectangle. We divided that rectangle up into 4 equal pieces, and then we selected 5 of those. So that right there represents my fraction 5/4. Let's look at another example dealing with our Army guys. So here's a statement, 9/8 of the collection of Army guys. So here's our collection of Army guys, consisting of those 8 people, or those 8 Army guys. And so our fraction 9/8 means that we're going to divide that collection up into 8 equal pieces. Well, it's already done so naturally. So each one of those guys is 1/8 of a collection. And so then it says we need 9 of those pieces. And so 9/8 of this collection is going to equal 9 Army guys. Okay. Now I don't have 9 army guys there, so I'm going to need to add another army guy. So let me draw a little army guy here real quick. Do, 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 do. So there's my 9th army guy. And so now, overall, that right there represents 9/8 of my collection. Okay? But to properly understand this picture, we have to remember that our whole consists of those army guys right there. If we don't understand what that whole is, then this picture isn't going to make any sense. So this again illustrates this very important point that we've made several times before. Defining the whole is critically important. If we don't understand what the whole is, then our fraction, our picture aren't going to make any sense. So let's do another example here of a fraction as a number. Draw a picture of the number 5 halves. So again, note that it's not 5 halves of something, it's just the number 5 halves. So to draw a picture of this, let's define the whole. And like in our previous example, let's just draw a little strip here, and we're going to label this as the whole. So now in our fraction, the denominator is 2. That means I need to divide that whole up into 2 equal pieces. And then our numerator is 5, so that means we need 5 of those pieces. Well, I don't have 5 pieces there, so I need to draw a second whole. Divide that up into 2 pieces again, and then we're going to need to draw a third whole here. So I've drawn 3 equal wholes, divided each of those up into 2 pieces, and so now I need 5 of those pieces. So there's 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces. So there, that picture represents this fraction 5 halves. And again, to properly understand this picture, we have to realize that this whole is one strip consisting of, or that has been broken down into 2 pieces. And again, it may sound like a broken record, but it's extremely important to remember that defining the whole is critically important. If we don't define the whole, the fraction and the picture aren't going to make any sense. Okay? So let's illustrate this with a simple word problem. So what fraction does the following picture represent? Well, this looks kind of like a picture we've drawn before, and so in order to interpret this as a fraction, we have to determine what is the whole. Well, this problem doesn't specify what the whole is, so let's look at a couple of ways that we could look at this. So we could first identify one strip like this as the whole. Well, if that's the whole, then the whole has been broken up into 3 pieces, and so in our fraction the denominator would be 3, and then we see that we have selected 1, 2, 3, 4, 5 of those, and so our numerator would be 5/3, or our fraction would be 5/3. So there's the fraction that this picture represents if we identify this one strip as being the whole. Well, let's look at another way that we could interpret this picture. Instead of interpreting one strip as the whole, let's take this whole picture to be the whole. Or I should say, let's take both large rectangles to represent the whole. So if that's the whole, we see that that whole has been broken up into 1, 2, 3, 4, 5, 6 pieces. And so in our fraction, the denominator would be 6. And we see that we have selected 1, 2, 3, 4, 5 of those, and so our numerator would be 5/6. So there's what this picture, there's the fraction that this picture would represent if we interpret the whole as this long strip consisting of 2 large boxes. So the problem with this word problem is that it was ambiguous. Ambiguous means that it really didn't give us enough information for us to definitively answer the question. Because the question didn't specify what the whole is, there's lots of different ways to interpret it. And when we write word problems, we do not want them to be ambiguous. We want to write questions in such a way so that there's only one answer. And so in order to rewrite this question, so that it's not ambiguous, we would need to define what the whole is. So here's one way we could say it. If the whole consists of 3 squares, meaning 3 little squares like this, what fraction does this picture represent? And so here in this problem we have identified this as the whole, and so that whole has been broken up into 3 pieces, and so we see that 5 of those have been shaded, and so the answer to this question would be 5/3. That's the answer to this unambiguous question. It's unambiguous because we have defined the whole as consisting of just 3 individual squares. Now our last example is going to illustrate how we can plot fractions on the number line. So let's plot the number 5/3 on a number line. Now notice that it's not 5/3 of something. We haven't specified the whole, and so this is just a fraction as a number. And so if we want to plot this on the number line, we first need to define what the whole is. And so let's do this like we've done before. Let's draw just a little strip here to represent the whole. And then on our number line, we're going to put 0 at the left end of that strip and then 1 at the right end. So this unit here from 0 to 1 is the same length as our whole there. And then our fraction is 5/3, the denominator is 3. That means we're going to divide this whole up into 3 pieces. And then the numerator is 5, so that means we need 5 of those pieces. And so we need to draw a little bit more than what's there, so we're going to draw 2 more pieces there. And so to plot the number 5/3, we're going to go over 5 pieces. 1, 2, 3, 4, 5. Put our dot there, and that's how we can plot the number 5/3 on a number line. So that's it for this lesson. Your assignment is to read pages 50 to 52 from the textbook.